Question 2, part B. Also find the minimum number of iterations needed for the above accuracy. So let's find that. So for that, we can use this theorem, error estimations for bisection method. Suppose that f is a continuous function on a closed interval AB such that the product of f times b less than 0 negative dimensions. There x is a root in between a and b. So let's take that root is p. Then if you f of p is equals to exact root in between a b. So this is the sequence p sub 1, p sub 2, p sub 3. This is your midpoints. So p sub 1 is the initial midpoint, alright, and the second midpoint is p sub 2, p sub 3. Here you can generate a sequence of numbers. Fourth midpoint, fifth midpoint, and you can generate an infinite sequence, right? And be the sequence generated by the bisection method. Then so any term, any midpoint, the difference between any midpoint and the exact root is less than or equal to the interval, the length of that interval divided by 2 to the n. So this one is very useful one. If you want to find the number of iterations, yeah, right? So in this question, find the minimum number of iterations needed for the above accuracy. Alright, let's use this inequality, right? Let me take my blackboard. Right, the difference between any midpoint in the sequence and the exact root of the function is less than or equal to the length of our interval divided by 2 to the power n, right? So this one is true for any midpoint, right? Any midpoint. That means for all n belongs to natural numbers, right? This one is true for all and any midpoint. So difference between any midpoint and the exact root of the function is less than or equal to the length of the interval AB divided by 2 to the power n. Right? This one is very important to find the number of iterations to that accuracy. So we need to find the number of iterations for the accuracy to the least, the accuracy 10 to the minus 10, 10 to the minus 4. Alright, so therefore, so this Pn minus P less than or equal, what is B minus A divided 10 to the n, not 2 to the n, should be less than or equal 10 to the minus 4. This is the accuracy. So you know A and B, A is 1 and B is 2. So the length is 1 here, B is 2, B2, A is 1, length is 1 here. you have, what you have, 2 minus 1 is 1 divided by 2 to the n less than or equal to 10 to the minus 4. So this implies you can cross multiply this number by this number, then and let's take this to the denominator here, so then that becomes 10 to the power 4 less than or equal to 2 to the n, right? If you want to take this exponent part to here in front of 2, you have to take log base 2, log base 2. Let's take log base 2 from both sides, and 10 to the power 4 less than or equal log base 2 of 2 to the n, right? This implies 4 times log base 2 of 10. You can take this power in front of log, right? If you right, and you can take this power exponent in front of log less than or equal n times log base 2 of 2 is 1. Then let's compute this one. 4 times log base 2 of 10. So let's try to find log base 2 of 10. So we want to find this value. Let's take y is equal to log base 2 of 10. So I want to get rid of log base 2. To get rid of log base 2, I take 2 to the power both sides, right? The left hand side 2 to the power y, and right hand side 2 to the power, this thing is same with 10, right? Then if you want to take this exponent part in front of 2, then take the log base 10. So take it like log base 10 both sides, and you can take y in front of log base 10 of 2, right? Y times log base 10 of 2 is equal to log base 10 of 10, which is equal to 1, right? Then y equals 1 over log base 10 of 2. Let's take the calculator, right? So log base 10. So here you have log. Let's clear this number. Enter 2, and log of 2 is this. We want 1 over that number. 1 over that number is equal to 3 point, is equal to what you have, 3.32. This is the approximate value. This value should be multiplied by 4. That value should be multiplied by 4. Then you get the number of iterations. Then what do you get? 13.3. Here you can write this value is approximately 13.3 less than or equal 10. Then what is the minimum number of iterations to get 10 to the minus for accuracy, so what is the minimum number of iterations to get 10 to the minus 4 accuracy is you need to consider 14 iterations to get 10 to the minus 4 accuracy. I hope you understood this one here. So this is the question 2, part B. We have done the first part, right? Show that the function has a root in between in this interval. That means you have to substitute endpoints and check the sign of product of f of 1 and f of 2. If it is negative, then we can say there exists at least a root in this interval. Right? And we use the bisection method to determine an approximate to the root that is accurate to at least within the relative error 10 to the minus 4. We have done that. And this one, find the minimum number of iterations needed for the above accuracy. Then we used this theorem, right? So the difference between midpoint, any midpoint, these are midpoints, initial midpoint, the second midpoint, third midpoint, we divide interval AB into small sub-intervals, right? So these are the midpoints of those intervals, right? So if you plug this one into here, this satisfies this condition here. P sub n minus P, modulus of that, less than or equal to the length of the interval, this interval, divided by 2 to the power n. So this one is very useful to find the number of iterations, minimum iterations for the given accuracy, right? I hope you understood that problem, right? See you in next video.